So guys, you can see we have two PICs over here. This is our transmitter, this is the receiver PIC. On the receiver PIC, the LED is connected. So the transmitter PIC sends a character T over the UART to the receiver PIC, and receiver PIC is programmed in such a way that whenever it receives a T, character T over the UART, it turns on the LED. And LED remains on for how long? It remains on for how long? That depends upon for how long the transmitter PIC is sending the character T. And for turning off the LED, the transmitter PIC can send any character other than T, like it sends the character Z, and it is sent for how long? The receiver PIC is programmed in such a way that it will turn that LED off for that long. So I show you the code. So in the programming over here, you can see we have two codes. First of all, we see the receiver code. Okay, this is the receiver code. On the receiver code, you can see that we just initialize our LED and gave it the initial state, that is off. Then we initialize the UART port. Then we are using this command to check if our receive buffer is ready to read the data, and if it's ready, then it reads the data and stores in this character variable. Because we are using this command, so we can only receive a character, and we have initialized this char character receive 1. So then after receiving the character, we check if the character is T, only then turn on the LED. Else, if it is anything other than T, it will turn off the LED. Now, since if the T is received once, then it will be stored in this variable rec1, and it will keep on repeating forever, like it will keep the LED on. To make sure that we don't go in that loop, we change the state of the receive variable, like we ourselves gave it any value other than T. I just gave it Z randomly, so it will become Z in the loop. So it will still wait. If T comes, only then the LED will be on. So that is of the receiver side. Now this is the transmitter side. On the transmitter side, we initialize the UART port, and we use this command UART TX idle if double equal to 1. This command makes sure that only the data is sent if the transmitter buffer is empty, else it will have errors. So then after it checks the transmitter buffer is ready to send the data, it sends the T. And now for how long it should send the T? It will send the T for 250 milliseconds. So that is why we will get a delay of 250 milliseconds for the LED blinking. See, on the receiver side, we don't have any delay for the LED on time. This will be decided by the transmitter side's delay. This delay will decide that. And now then we, after sending a T, to make sure that we also turn off the LED, we check if the transmitter buffer is ready, and then we send a Z. Any character other than T will do. So we just send a Z. If Z is sent, this means that any character other than T else will turn off the LED. So it's Z. So that's how this is working. So you can see over here, this is a demonstration of PIC-to-PIC communication over the UART port. Hello guys, welcome to learning microcontrollers. In this video, I will show you how you can do PIC16F877A to PIC16F877A UART communication, and we will blink an LED. So we will have an LED on one PIC, and from the other PIC we will send a signal, and that signal will cause the LED to turn on and off depending upon our requirements. So let's do this exercise. So guys, this over here is our first PIC, this over here is our second PIC. I've just inverted them for wiring purpose. Now let's do the wiring. As you know, this will be a small circuit but very useful for your future applications. Now here you can see C6 and C7 pin. Now in the PIC16F877A, pin number C6 is the TX pin of the UART port, and C7 is the RX pin of the UART port. C6 is the pin number 25, C7 is the pin number 26, and PIC16F877A has only one UART port, and that is situated over here, and this is the hardware UART. So let's do the connection. So you will connect, that is pin number C7 of your first PIC16F877A, that is pin number C7, the RX pin, to the TX pin, that is pin number 25 of your second PIC. TX goes to RX, that's how your UART communication works. So TX is connected to RX. Similarly, RX will go to the TX. So pin number C7, that is pin number 26, is the RX pin. This will go to the C6 of the other PIC. So RX to TX or TX to RX. That's how we do the connection. Now, since one more thing is necessary, only two wires are required for the UART communication. We also need another wire, that is the ground. Ground of both the microcontrollers must be common, else our communication may work and may have certain errors. If the ground is common, there will be no error. So this is necessary. Now we also connect the LED. So with one of this, we will connect the LED. I connect LED with this one. So this is our LED, crystal type 5mm LED, easily available in the market. Now to connect it with the PIC, you need a safety resistor. This makes sure that your LED do not get burned. and the value of this resistor depends upon you, how much brightness you want for your LED. Higher the value of the resistor, the dimmer the LED will go. So my resistor value is 220 ohm, that's ideal. So let's do the connection. So this LED have two pins, one longer, one shorter. The shorter is always the ground, the longer is always the power. For the shorter pin, you connect it directly to the ground of your both the microcontroller, the common ground. That's how you do the connection. Now for the longer pin, you connect it to the one end of the 220 ohm resistor like this. From the other end, you can send it to any available GPIO pin. I will use the pin number B0 like this. Now this is simple circuit. So with one PIC we have the LED, with other PIC we don't have the LED. We will program this PIC in such a way that whenever it receives a command from this PIC, it will turn on the LED. So we will program this PIC in such a way that like it will keep on sending a command, like after every 250 millisecond it will send a command to that PIC to turn on the LED, and after 250 millisecond it will say turn off the LED. So this means the LED will keep on blinking based upon the command sent from this PIC. While this PIC will not have any delay command, this will only have a command to read the data coming from the other PIC and then do the LED blinking as per the command given by this PIC. So this will be our simple exercise. So let me introduce you to the hardware, then we move on to the programming. Guys, this is the hardware over here. You can see this is my first PIC and this is the second PIC. On this PIC I have the LED connected, this LED, this is the LED we have connected over there. So this will be the receiver PIC and this will be the transmitter PIC, and wiring is as shown in the presentation. So the rest is just a trainer board. So let's get to the micro C to get started with the programming. So guys, this is the micro C. Let me zoom in. Go to the left, click on File, New Project. This window pops up, New Project Wizard. Click on Next, write the name of the code. So we will be having two codes. One will be for the transmitter side and one will be for the receiver side. So let's write the receiver side code first. So I name it like receiver PIC to PIC code 1. Okay. And I have PIC16F877A microcontroller, and select the crystal that you have connected with that board. So on my receiver board, I have a crystal of 20 megahertz connected to the pin number 13 and 14 of the PIC16F877A. So I select that, click on Next and click on Finish. Wait for the window to appear. Okay, this is the window. Before you do anything else, go to the file and click on Save. First of all, save your work. Click on Save. Now guys, we will need the UART port because we are using the UART communication. Go to the right. In the micro E libraries expanded, the system libraries expanded, go to the bottom. There you have this UART. You check mark this library expanded. There you have this command called UART1I90. Double click on this. This window pops up, and here you have this command there, UART1I90-9600. Now this is a command to initialize the UART port of the PIC16F877A with your desired baud rate. So the baud rate by default is 9600. So this will be fine, this will do. We have to set same baud rate for the receiver and the transmitter. So we are writing the receiver code first. So we can set any baud rate. Then we will set the same for the transmitter side as well. So give some initialization delay. I always suggest you give it in the one-time loop. 100 millisecond will do fine. Okay, this is it. So for the receiver side, we have this UART port. The second thing is an LED. We also have a LED connected to the port B, pin number B0, that is pin number 33 as shown in the presentation. So I initialize that LED as well. Trace B.F0 equals to 0. Trace is the direction register, B is the port name, F0 is the pin name, and 0 means the pin has been declared as an output pin. So for the LED, we need an output pin. Now initially I want the LED to be off, so I give it an initial state of 0. Port B.F0 equals to 0. So this command will make sure that your LED is 0 by default. We have given it an initial state of 0. So we also give initialization delay over here as well. Not necessary, but I always suggest you give it in the one-time loop. There we go. Now we can go for the forever loop. For the receiver side, while one forever loop starts here and here and here, we will do our programming. So first thing is, since we know that we are going to read the data coming from the UART port, so we need to read the data coming from there. So go to the right. In the UART library, you have this command called UART1 read, and go for this command UART1 data ready, because this will also make sure your data is not received in error forms. Okay, now this command UART1 data ready double equal to 1 is a check. If the receive buffer is getting the data, only then it will read the data, and this is the variable to store the data. We can initialize any variable, a char variable char, I call it rec1, or any name you can give. Rec1 is a variable which will store the data. So I replace this with this. So if UART1 data ready, it means that if the RX buffer of your UART port is getting the data, then receive1 is equal to UART1 read. This means that a single char will be received. The difference between these two commands, the UART1 read and UART1 read text, is that this can read a whole array of char, that means a string, while this one only reads a char. So this can be only a one character. So that is what we will do at the transmitter side. So this will read the character. Now it's up to us to program it. I call it like if the received data rec1 is double equal to if we receive t. Okay, any variable will do t, the char. Okay, t. If a t is received, then what it should do? It should turn on the LED. So LED by default is at 0. We make it go on. We make it like 1. So if a t is received, the LED will be turned on. So that's what we will do with the received data. And else. Now we write the else. Else if t is not received, anything else is received, then keep the LED off like this. And since we are only playing with the t, if t is not received, but if t was received one time, then it will have the t in the in this variable. So we have to remove that manually. So we give it another state here. So if the t is not received, it will go to some other state, like we make it something like z. So it will also change the state of the rec1 register, else it will keep on rec1 variable, else it will keep on repeating, because rec1 will have a t if it got the t. And also we do the same in the one-time loop as well over here as well. So by default we give it a different state. Any state other than the one being used in the code you can give over here. It can be any symbol or anything. If you don't do this, then there will be a problem. Like if you receive the t one time, then it will be stored in the variable and it will keep on repeating until you do not reset the code. So that's what we do. You can also remove this, it doesn't matter, because it will keep on updating. Okay, this is it. This is our code for the receiver side. I built this code. Okay, successfully built, no errors. So this is the code for the receiver side only. Okay, now we write the code for the transmitter side. Now to do that, okay, first we also burn this as well. Okay, I go to the PIC16 programmer tool. This is my PIC16 programmer tool. I click on file, import. This is the code we just wrote. I click on write. Okay, the receiver side code is being written. Let me show you the hardware. So you can see the PIC16 is connected to the receiver side, that side, because we have the LED connected to that board. So you can see the code is being burnt. Wait. Then we write the code for the transmitter side. Okay, it's being done. Let's go back. Until this is done, we start writing the code for the transmitter side. I go to the start page, click on file, new project. This window pops up, new project widget, click on next. And instead of receiver, I make it transmitter. Pic to pic code 2. PIC16F877A is the microcontroller I have, and the crystal I have on the transmitter board is 16 MHz. It doesn't matter if your device is different, you have to select the correct device. If your device have a different crystal, just make sure that you select the correct crystal over here when writing the code. Rest will be fine. Click on next and finish. Okay, there we go, the transmitter side. Before you do anything else, again, save your work. Click on file, save. Okay, it's saved. Now again we are using the UART port, so go to the right in the micro E libraries, expanded, system libraries, expanded, go to the bottom, you have this UART, check mark this, expanded, there you have the UART1 I90, double click on it, this window pops up, there you have this command UART1 I90 9600, go back, paste it here, and the baud rate we set on the receiver side was the same, that is 9600, so we should have the same baud rate on the transmitter side as well. We give some initialization delay over here as well. Now since we don't have any other component on the transmitter side, so we will go for the forever loop after initializing the UART port. While one, so UART port we start initializing. Okay, sorry, we are writing the forever loop starting from here, ending to here. Now for the transmitter side, since we know on the receiver side what we did is that we are using T, this character T is, this means that LED will be on. If we send anything other than T, this means that LED will be off. So what we do is that we write a code. So go to the right. Here you have this command called UART write, this one. Double click on it. This is the command UART write. Okay, instead of this, go for this UART1 TX ideal, double click, same command but in a better way. Okay, now copy this whole, go back, paste it. Okay, like this. Now this is the command to send a character, and this command, if UART TX ideal, this over here is a check. If the TX buffer is ready to send the data, only then send the data, else don't send the data, because the data you will send will be racked and bagged. That will have errors. So that's why we are using this safety. You can use this command directly as well, but it may have error. Now you see on the receiver side, if we send a T, it means that LED is on. So we send a T. I send a T. T. Okay, there you go. The T will be sent. And we also give a delay, like for how long we want the LED to be on, because T will be sent and then it will remain there in the receive buffer. For how long I want this to be on, T will be sent there for like 250 millisecond. Okay, that will do fine. So a T is sent and it will be like this for 250 millisecond, and after that we write the second loop. Okay, again now we send a Z. So this means that anything other than T, like X, A, B, C, or whatever you prefer, whichever character you send will do. So we just write as Z. So it will send a T for 250 millisecond. It means the LED is on for this and LED is off for this, or any character other than T. We build this code, built, no error. We build it again to verify. Okay, still no error. Okay, that's perfect. Now let's open the PIC16 programmer tool. Okay, I zoom in, click on file, import hex file. Okay, let me show you the hardware. Let me move the PIC as well. See, the PIC is connected to receiver side. Now I move it to the transmitter side. So this is the transmitter side. Here, so there we go, the transmitter side. Now the PIC is at the transmitter side because we want it to be at the transmitter side. So I bring the LED over here so you guys can see if it blinks or not. Okay, let me change the positions a bit. I take it there, there. The LED should be easily visible. Okay, that will be fine. Okay, now the PIC is at the transmitter side. Now we go to the PIC3 programmer tool. This one. We bring our hex file. Click on file, import hex file. Now this is the file we wrote for the transmitter, PIC to PIC code. Double click, click on write. Okay, wait for the new code to be written. Both devices are powered up by the same PIC3, so no need to worry about the power. Okay, let it power up. Then we power up the whole circuit using the same PIC3. Okay, click on this on to power up both the circuits. Okay. Okay, let me. Okay, you can see the LED is blinking with a delay of 250 millisecond. While we have not given delay ourselves, or we have not used a toggle command, what is happening here is that these two PICs are communicating with each other. Like that PIC over there is a receiver and this one is a transmitter. This PIC is sending a signal. It sends a T to that PIC over the UART. If it receives the T, it then turns on the LED, and then we have made sure that it sends the T for 250 millisecond. Then it remains on for 250 millisecond, and then it sends any other character like Z, and then it turns off, and then it keeps on toggling. So guys, this is how we make this work. This is just a demonstration, and in the future I will make more complex video using PIC to PIC communication. So this was just a demonstration video for you guys to learn. If you have any questions, please do ask. So we'll see you in the next lecture. Goodbye until then.